Welcome you all to Alpha and Omega Mathematics by Vijay Jackson. Let us do problems based on group theory. So the question is now, if M2 is a set of 2 by 2 non-singular matrix over R, that is M2 is equal to set of all A, B, C, D. The elements are A, B, C, D belongs to capital R and AD minus BC is not equal to 0. And prove that M2 comma star is a group under multiplication. So see here, the given set is now set of all 2 by 2 matrices. And also we are considering non-singular matrix. So what is non-singular matrix? Non-singular matrix determinant answer is not equal to 0. So here the question itself, it has mentioned AD minus BC is not equal to 0. So our part is, so we are proving the set of all 2 by 2 matrix is a group under multiplication. So for proving it is group, so we are going to check 4 axioms. What are the axioms we are going to check it? The first axiom is closed property. Then the second axiom is associative property. Third is identity element. Fourth one, finding the inverse element. So if the given set satisfies these 4 conditions, we can conclude it. The given set is a group under multiplication. So let us start our solution. So given set, write it. M2 is equal to set of all A, B, C, D such that A, comma B, comma C, D belongs to capital R, real numbers. So here the first property, so to prove that M2 comma multiplication is group. So first condition is closed property. So closed property says, suppose take 2 elements from the given set. Just to take it 2 elements from the given set. So just to take the multiplication of the given 2 elements. So find out the answer again belongs to the same set or not. So I'm taking here. So just 1, 2, 3, 4, comma, minus 1, 0, 1, 1 belongs to M2 of R. Just consider 2 elements, 2 matrices. Here see here all the elements are from capital R. All the elements are from capital R. Now take the multiplication 1, 2, 3, 4 into minus 1, 0, 1, 1. Multiplication says 1 into minus 1, minus 1, minus 1 plus 2, set as 1. First row into second column. So 1 into 0, 1 into 0 here. 1 into 0 is 0 plus 2 into 1 is 2. So the next element is 2. So again here 3 into minus 1 is minus 3 plus 4 into 1 is 4. So the answer is 1 now. The last value is 3 into 0 plus 4 into 1. So the answer is 4. So see here. So after taking multiplication of these 2 matrices, again we have got the matrix. It is also order is 2 by 2. So again see here the elements are from capital R, 1, 2, 1, 4. So these elements belongs to capital R. Definitely this is belongs to M2 of R. So therefore M2 of R is closed now. Is closed under multiplication. So now to check associative property. Associative property. So just to take it at 3 elements from M2 of R. So for proving associative property. So take 3 matrices from M2 of R. I'm taking here 1, minus 1, 0, 2. The second matrix is, you can take it any one. 5, 2, minus 1, 0. Then the third matrix is 1, 0, 0, minus 1. So this is belongs to M2 of R. So we are checking now associative property. So take the multiplication between first two matrix. So the resultant matrix, multiply it with other matrix. So here 1 minus 1 0 2 into 5 2 minus 1 0. Multiplication is first row into first column. 1 into 5 minus 1 into 1. So the answer is 6. 1 into 2 plus minus 1 into 0, it is 2. So 0 into 5, 0 plus 2 into minus 1, it is minus 2. Again 0 into 2 plus 0 into 2, it is 0. So the first two matrix multiplication is 6, 2 minus 2, 0. So multiply it with the third matrix 1, 0, 0 minus 1. So the answer is now 6 into 1, 6, 2 into 0, 0. So we have got 6. First row into second column, see here. 6 into 0, 0 plus 2 into minus 1, it is minus 2. Minus 2 into 1, minus 2 plus 0. This is minus 2. The last value is minus 2 into 0 plus 0 into minus 1 is 0. So again see here, we have got another one matrix. 6 minus 2 minus 2, 0. So now the same way, so here we have multiplied the first two matrix. So after that we have multiplied the result matrix with the third matrix. So now we are going to do the multiplication between second and the third matrix. So we multiply it second and third matrix. Then check that again we are multiplying with first matrix. So see here. So 5, 2, minus 1, 0, 1, 0, 0, minus 1. Multiplication. Now, first row, 5 into 1 plus 2 into 0, it is 5. 5 into 0 plus 2 into minus 1 is minus 1, minus 2. Minus 1 into 1 plus 0 into 0, it is minus 1. Minus 1 into 0 plus 0, it is 0. So the resultant matrix, multiply it with the first one. So 1 minus 1, 0, 2. So see here, 5 into 1 plus 0 into minus 2. So you are multiplying this way, right? So here, 1 minus 1, 0, 2 with this matrix. 5 minus 2 minus 1, 0. So 1 into 5, 5, minus 1 into minus 1 plus 6, plus 6. So 1 into minus 2, plus minus 1 into 0, minus 2. So 0 into 5, 0. Again 2 into minus 1, this is minus 2. So 0 into minus 2 plus 0 into 2, this is 0. So see here, in the left hand side, we have got this answer, 6 minus 2, 0. Right hand side also, you have got 6 minus 2, 0. Therefore, we have proved now A into B into C equal to A into B into C. So, therefore, M2 of R is associative. Associative property also holds now. Associative property holds. So what is the third property? The third property is we are finding the identity element of the given set M2 of R. So third property to find the identity element. So what is the identity element of 2 by 2 matrix? So identity element, here we are considering the unit matrix of order 2 by 2. So unit matrix 1, 0, 0, 1, this is equal to. So see here you can take it any one of the matrix 1, 2, 3, 4. Multiply it with unit matrix. Any matrix with unit matrix we'll get the same matrix. So 1, 2, 3, 4. So see here. So you can take it any one of the matrix, multiply it with unit matrix. So you'll get the same matrix. Therefore, we can conclude it now. 1, 0, 0, 1. This unit matrix is the identity element of this, this set M2 of R. So therefore, we have calculated 1, 0, 0, 1 is the identity matrix of M2 of R. So what is that fourth property? We are finding the inverse element. So inverse, so see here, inverse property says, inverse property. So says A star E equal to A. This is the inverse property, A star E equal to A. So see here, so for finding, just to take it any one of the matrix like that, A, B, C, D. In general, we are taking A, B, C, D. So A into, here this is actually identity. A into A inverse is equal to E. This is the inverse property. A star A inverse is E. So suppose the matrix we are taking in general, A, B, C, D means, so A inverse is D divided by AD minus BC. Here minus B divided by AD minus BC. So here minus C divided by AD minus BC. Here it is A divided by AD minus BC. So multiplying these two, so you'll get the answer is 1, 0, 0. So see here, the inverse property says A star A inverse is equal to E. A star A inverse is equal to E. So here, our set is having matrices elements. Therefore, so here how to find inverse of the matrix? So you'll find it determinant of A. Then we are calculating adjoint of A. So therefore, A inverse is equal to adjoint of A by determinant of A. This way only we are finding the inverse of any matrix. So here I have considered in general the 2 by 2 matrices A, B, C, D. So here the determinant answer is A into D minus B into C. A into D minus B into C. So actually AD minus BC is not equal to 0 in the problem it is given. So therefore we can calculate it inverse now. So here just interchanging A and D elements in the main diagonal. The sub-diagonal just to change the sign alone. So for finding inverse of 2 by 2 matrix, we calculate it this way. So just write it D divided by, so multiplying these two matrices, we'll get definitely identity element, identity matrix 1, 0, 0, 1. So see here now, M2 of R, this set satisfies all the four properties here. So the question is given M2 set of all ABCD elements. ABCD are from capital R. So you have proved now closed property. So just you have taken two elements from the given set. So after multiplying this, again you have got 2 by 2 matrix. So it belongs to the set M2 of R. So therefore M2 of R is closed under multiplication. So then we have proved associative property. So then we calculated identity element of M2 of R. This is actually unit matrix is the identity element. So again inverse property. So inverse, for finding inverse we have applied the formula A inverse is equal to adjoint of A by determinant of A. So by using this we have got inverse property, inverse also, inverse of each element of M2 of R. Then we can conclude it now. So therefore M2 of R is a group. It is a group under the binary operation under multiplication. So it is a group under multiplication. So this way we are proving the given set is a group under the binary operation. So let us do the next question. So based on the matrices. So the question is now, let G denote the set of all matrix to form. Here the elements, see here. Will you able to see the difference between the previous one and this problem? Where X belongs to capital R. So prove that G is a group under matrix multiplication. So here the previous problem, there also we have taken 2 by 2 order 2 by 2 matrix. But see here the elements are different elements. Inside the elements are different elements. But here also we are considering 2 by 2 matrix. So our set is now 2 by 2 matrix. But see here the elements are, all the elements are same elements. So inside the matrix the elements are same. For example, suppose X may be 5 means the matrix is 5, 5, 5, 5 like that. So here, so this is the different matrix. This is the different matrix of 2 by 2. So here also you are proving G is a group under matrix multiplication. So how we are going to prove it? See here. So first property is we are checking now closure property. So to prove capital G is equal to set of all x such that x belongs to capital R is a group under multiplication. Under multiplication. So first one is check that closure property. Closure property. So what is closure property? Take any two elements from the given set, multiply it. So again check that whether the answer belongs to the set or not. Okay. So here our matrix is 2 by 2 matrix, but here the elements are same elements. I take 1, 1, 1, 1, comma, 2, 2, 2 belongs to capital G only. So multiply it. 1, 1, 1, 1, 2, 2. This is some multiplication. 1 into 2 plus 1 into 2. So it is 4. First row into first column. First row into second column. 1 into 2 plus 1 into 2. This is also 4. So again, the second row with the first column. 1 into 2 plus 1 into 2. It is also 4. Second row with the second column, 1 into 2 plus 1 into 2, it is 4. So see here, we have got one 2 by 2 matrix now. Check the element, check all the elements, the same element. See here, 4, 4, 4, 4, 4. Therefore, this is belongs to our set capital G. So therefore, it is closed now. Then check the second property, it is associative. So associative property, consider 3 elements from capital G. So here the same, like take 1, 1, 2, 2, then 3, 3. You can take anything, belongs to capital G. So find out the left side, 1, 1, 1, 1 into 2, 2, 2, 2 with 3, 3, the third matrix. So by the previous property, we have found 1, 1, 2, 1, 1, 2, 2, 2, 2 multiplication is, this is 4, 4, 4, 4. So here multiply 3, 3, 3, 3. So now to check what is the answer, we will get it. So see here, multiply it now, 4 into 3, 4 3s are 12, plus 4 3s are 12, this is 24, plus again first row into second column, 4 3s are 12 plus 4 3s are 12. This is also 24. Now 4 3s are 12 plus 4 3s are 12. Here 24, the last value, last row into second row into second column. So 4 3s are 12 plus 4 3s are 12. This is 24. So again, see here, the result value 24, 24, 24, 24. This check it whether it belongs to capital G. Yes, it belongs to capital G. It is a 2 by 2 matrix. All the elements are same elements. So this is left side. Now then find out right side. So you have got a left side answer. So now right side answer. So for finding right side, first multiply it 2, 2 here and 3, 3a matrix. So multiplication now. So 2 3s are 6 plus 2 3s are 6. This is 12. So again first row into second column is also 12. Here also we have got the answer is 12, 12, 12. So again, so therefore 1, 1, 1, 1 into 2, 2, 2, 2, 3, 3, 3, 3. This is equal to 1, 1, 1, 1 with 12, 12, 12, 12. Multiply it now. So 1 into 12 plus 1 into 12, this is 24, 24. After taking multiplication, you have got this answer. So check the answer. This belongs to capital G. And in the left side, you have found this answer. 24, 24, 24, 24. Right side also, you have got the answer is the same answer. So therefore, you can conclude it. A into B into C is equal to A into B into C. So therefore, G is associative. And multiplication. So G is associative now. So then find out. So now to find identity element. Identity element, how we find it? So identity property says A star E equal to A. A star E equal to A. A. So here our element is A. Take it A. This is our matrix. Okay. So int E, write it E. This is equal to, so multiplying, what we get? A. We have to get, so to find the value of E now, this is actually procedure of finding identity element. This is procedure of finding identity element. A into E is equal to, you have to get the same matrix. So multiply it. So A into E plus A into E. So 2 times A. So again the next element first row with the second element, this is also 2AE. So here 2AE, here also 2AE. So again in the right side you have got A. So see here, so we are finding the value of E. So now we can equate these two matrices. So when we equate two matrices, so order must be same. It is 2 by 2 matrix. Here also 2 by 2 matrix. So order is same. Therefore, we can equate it. So the corresponding position elements 2AE is equal to A. A will be getting cancelled. So you have got the answer is 2E equal to 1. Therefore, E is answer is 1 by 2. So therefore, the identity element, what is the identity element? Identity element is 1 by 2, 1 by 2, 1 by 2, 1 by 2. This is the identity element of this particular group. So E, we have got the answer is 1 by 2, 1 by 2, 1 by 2, 1 by 2. Then find the fourth property. So fourth property says to find the inverse element. So fourth property is to find inverse element. So here inverse property says A star A inverse is equal to E. A star A inverse is equal to E. So see here A matrix is now. Okay. So A matrix is, we have got A like that. So multiplying with inverse matrix. So this is equal to multiplying this E. That is the answer. Okay. So here A. I have taken, I'll take here X. Okay. X is the inverse of the matrix A. So here multiply it AX plus AX. So 2 times AX. Here also 2 times AX. 2AX, 2AX in the left side. Right side, you can put it E by 1 by 2. By using the previous property, we have found E is equal to 1 by 2. So 1 by 2, 1 by 2. So now we can equate it, these two matrices, because order is same. So corresponding position 2ax is equal to 1 by 2. So we are calculating the value of x. So therefore x is equal to 1 by 4a. So now we can write the inverse element. So therefore the inverse element is here. The inverse element is 1 by 4a, 1 by 4a, 1 by 4a, 1 by 4a. So see here, so you have taken a matrix A means, so here the inverse element is 1 by 4a, 1 by 4a, like that. So suppose here you have taken a 2, 2, 2, 2 matrix means, for finding the inverse element of 2, 2, 2, 2 means, in the place just to put it a by 2, a equal to 2. So you get the inverse element of the matrix 2, 2, 2, 2. So here, so each matrix by using the same, by using this 1 by 4a matrix, so you can write it the inverse element of all the matrices, like the matrices of order 2 by 2 has same elements. So this way we are finding inverse elements. So now see here, we have proved all the four properties. So closure, associative, identity. So see here, so this is we have proved closure property. So then associative property. So after that, identity element we have proved. Okay, we have calculated identity E values 1 by 2. Then finally we have found the inverse element of the given matrix. Then we can write the conclusion. The conclusion is, what is the conclusion? So therefore the given set G equal to x is such that x belongs to capital R, is a group under multiplication. So the same way we can do any problem related with groups. So for checking group, or whether we check it is an abelian group or not. So here by using the same way, so first property, check it closed. So after that, check it associative. Third property, identity. Fourth is A inverse. So suppose for proving abelian group means you have to check one more property, that is commutative property. So commutative property is A into B is equal to B into A. So this is under multiplication. Here under addition means A plus B is equal to B plus A. So if you prove like that, we can conclude it is an abelian group. Like we can do any problems related with group theory.